Hey there, and welcome to this explainer. Let's just jump right in, shall we? Have you ever looked up at a towering mountain peak, or stared at a winding river valley, or maybe a massive desert sand dune, and just wondered, how did that actually get there? It's super tempting to think of the Earth's surface as this static, unchanging thing, but honestly, it is a grand, sweeping canvas that is relentlessly being reshaped by natural forces. Today, we are going to explore the master sculptors of our planet, the elements that carve, smooth, and build the entire world around us. Think of this explainer as a quick, guided tour through nature's 5 distinct art studios. We'll be looking at Earth's relief and rivers, coastlines and the crashing waves, glaciers as rivers of ice, wind, the desert architect, and finally, karst, the underground world. But wait, before we step into that first studio, we kind of need to establish the rules of the game. You see, our planet is shaped by 2 very distinct types of forces. Endogenic, or tectonic forces, are your heavy lifters. They push up from deep within the Earth to build mountains and continents. They basically provide the raw block of marble. Exogenic forces, on the other hand, those gradational forces like water, wind, and ice that we're focusing on today, well, they're the chisels. They take that raw tectonic crust and they erode it, transport it, and deposit it somewhere else to create the incredible relief features we see every single day.
All right, let's move right into our first sculptor, Earth's relief and rivers.
Fluvial forces are probably the most common sculptor we interact with. And rivers, they don't just gently flow. Through a process called hydraulic action, the sheer, raw impact of water currents physically breaks down the rocky sides of a valley. And then, through attrition, the rocks and debris carried by the river are constantly smashing into each other, wearing themselves down like giant geological sandpaper. And what's really cool is that just like us, rivers actually have a life cycle: youth, maturity, and old age. In its youth stage, usually way up in the steep mountains, a river is violent, right? It's highly turbulent. It aggressively cuts downwards, causing vertical erosion that creates steep, V-shaped valleys, dramatic waterfalls, and really tight gorges. Then, as it hits that mature stage, it calms down a bit. It widens out, cutting laterally to create sweeping meanders. Finally, in its old stage, the river gets slow. It literally lacks the energy to carry heavy materials anymore, so it drops its cargo, relying on deposition to form wide floodplains and massive deltas right before it finally meets the sea. Which brings us to a super important point. Our fluvial sculptor has 2 totally distinct personalities. First, we've got the destructive artist. This is the erosional river that gouges out deep gorges, drills potholes into solid rock, and carves these complex interlocking spurs. But on the flip side, we have the constructive artist. Through deposition, the river builds up the land, creating rich, fertile deltas, natural flood protection levees, and vast alluvial fans. It literally tears down mountains just to build up the plains down below.
Okay, let's leave the rivers behind and head over to our second studio, coastlines and the crashing waves.
Out here, the ocean uses the relentless power of tides and currents to just hammer the edges of our continents. Every single time a wave breaks, water rushes up the beach. That's a process known as swash, and then it drags material back down into the sea through the backwash. It is this never-ending rhythmic cycle of erosion and deposition. And I gotta tell you, this sequence of coastal erosion is incredibly violent, but also highly systematic. First, hydraulic action punches a hole straight into a coastal cliff, forming a sea cave. Over time, if this happens on both sides of a narrow headland, those caves eventually connect to form a gorgeous bridge-like sea arch. But the waves, they never stop. They keep pounding until the roof of that arch inevitably collapses entirely, leaving behind an isolated pillar of rock that we call a sea stack. Finally, even that towering stack gets eroded down by the waves into a mere stump. Step by step, solid rock is completely dismantled.
But get this, coastal landscapes aren't just shaped by waves, they are also dramatically altered when the sea level itself changes. When the sea level rises and floods the existing topography, we get what are called coastlines of submergence, and nature provides some absolutely stunning variations here. If the sea floods a regular mountain valley, you get the branching V-shaped ria coasts, like you see in northwest Spain. If it floods a deep U-shaped valley that was carved by ancient ice, you get the breathtaking fjords of Norway. If it floods parallel mountain ridges, you get the island-hopping Dalmatian coasts of Yugoslavia. And if it just floods a low-lying river mouth, you end up with an estuarine coast, kind of like the Thames in Britain. It's the exact same rising water, but painting on completely different canvases.
Now let's dramatically slow things down for our third studio. Glaciers, the literal rivers of ice. Roches moutonnées. Honestly, it sounds like a delicate French pastry, doesn't it? But it's actually an incredibly violent geological feature. Because of their immense crushing weight, glaciers reshape the Earth using two massive forces. When a huge glacier moves over a hill of solid rock, the side facing the oncoming ice, which is called the Stas side, gets smoothed and polished completely flat by grinding abrasion. But as that ice passes over the top and moves down the other side, the lee side, a process called freeze-thaw plucking kicks in. The ice literally freezes around chunks of solid rock and just rips them out of the mountainside, leaving the back end completely jagged and rough.
Glaciers also leave behind some pretty incredible bodies of water. When an armchair-shaped hollow, originally carved out by a glacier, eventually fills with water, it's called a tarn. But check out this wonderful description from our source material. When multiple tarn lakes are carved out sequentially, straight down a glacial valley, they look exactly like a string of prayer beads, which is why they are beautifully named Paternoster lakes. It's just such a great visual metaphor, makes the whole concept super easy to remember.
But look, glaciers are also intensely dangerous environments. The very intimidating German word Bergschrund perfectly describes our next feature. It is a massive, incredibly deep crevasse or crack that opens up right along the headwall of a glacier. It forms exactly where the moving ice pulls away from the stagnant ice that's still attached to the mountain. It's a fundamental feature of glacial movement and, as you can imagine, a major hazard for any mountaineer trying to navigate these icy giants. And just like those rivers we talked about earlier, glaciers are both destroyers and builders. Notice how glacial erosion creates this sharp, dramatic violence. When multiple glaciers eat into a single mountain, they leave behind towering, jagged, pyramidal peaks, or horns, and razor-sharp, knife-edge ridges called arêtes. But when those glaciers finally melt, they just drop everything. Well, actually, indiscriminately dump is probably a better way to put it. They just dump all the rocks and debris they were carrying. This totally disorganized dumping creates bizarre, unassorted depositional features, like those elongated hills known as drumlins, winding ridges of gravel called eskers, and massive mounds of boulder clay known as moraines.
All right, let's thaw out a bit and transition over to our fourth studio, wind, the desert architect.
Here, wind acts like a relentless, massive sandblaster. But a really crucial point to understand is exactly where this artist works. You will find most of the world's true deserts confined geographically to a very specific latitudinal belt, right between 15 degrees and 30 degrees north and south of the equator, due to a very specific combination of cold ocean currents, low rainfall, and high atmospheric pressure. This exact zone is where you'll find the sweeping, sandy ergs of Saudi Arabia and the barren, rocky Hamada deserts of the Sahara.
So let's flip through the wind's portfolio. In arid environments, where there is basically no vegetation to hold the soil down, the wind uses processes like deflation and abrasion. Through this intense sandblasting power, it polishes individual stones into smooth, flat-faced ventifacts. It also carves away the softer rock to leave behind flat-topped, table-like mesas and those crazy, gravity-defying mushroom rocks, where the softer base is literally eaten away by low-flying sand. But the wind builds stuff too. Through deposition, it creates ever-shifting sand dunes. We get the classic crescent-shaped Barchan dunes, the long single-winged Seif dunes, and vast, sweeping deposits of fine, wind-blown dust known as loess.
Finally, let's move on to our last sculptor, karst, the underground world.
For this one, we have to travel completely out of sight. This is a realm of quiet, hidden chemical artistry. Unlike the brute physical force of waves or glaciers, this artistry happens in regions made of limestone or dolomite, where mildly acidic groundwater slowly and patiently dissolves the rock right beneath our very feet. And let's walk through how this builds, because this slow chemical dissolution actually creates some massive dramatic collapses up on the surface. It starts really small, with a simple surface depression called a sinkhole. Over time, as more of that rock dissolves, multiple sinkholes coalesce into a much larger, more dangerous swallow hole. The chemical erosion just keeps eating away at the rock, widening the gap into an even larger doline. And ultimately, these can merge into massive, extensive depressions known as uvalas, quite literally swallowing entire valleys into the subterranean world. But inside those underground caves, the dissolved limestone doesn't just vanish into thin air, it gets redeposited, which creates a classic bit of geological confusion. So here's a super easy trick to remember the difference. Stalactites hold tight to the ceiling and grow downwards, and stalagmites might reach the roof one day, so they grow upwards from the cave floor. Simple, right?
And when these slow drip deposits eventually meet in the middle, they join together to form massive, totally spectacular vertical cave pillars.
Well, we've officially toured the 5 great studios of Earth's exogenic sculptors. We've seen how rivers carve out valleys, how the oceans dismantle cliffs, how glaciers literally bulldoze mountains, how wind sandblasts the desert, and how groundwater dissolves the Earth from the inside out. So here is a question for you to take away from this explainer today. Step outside later and really look around. Which of these 5 master sculptors is at work right now reshaping your very own local landscape? Keep your eyes open, you guys, because the Earth's grand canvas, it is never truly finished. Thanks so much for joining me on this explainer, and keep exploring.